Hello everyone, welcome back to our lecture series. Emeka Udenze is speaking once again. Today we'll be looking at esters, nomenclature. So our basic topic today is just the nomenclature of esters. And this is going to be a very short lecture. Let's kick it off immediately from there. I have a beautiful quote here from someone very popular in American screen, Will Smith. He says the first step is you have to say that you can. This is a food for thought. Just know that anything you put your mind to do, no army of this world can stop you from achieving that. All right, let us immediately get into the lecture. Now, we have just one basic learning objective to address. We'll be addressing how to name and draw the structural formulas of Esther. So, our learning objective today is to use IUPAC to name esters and draw their structural formulas. That is just the basic thing we're going to be doing in this class. Let's take it off immediately. Esters. Now, the ester functional group is a very common functional group we see in everyday life, in food, in product, in household items, and all the rest of them. So the ester functional group, of course, we've introduced this even when we talked about carboxylic acid, and particularly again when we talked about different functional groups in earlier modules in this class. So the ester functional group is the key structural component or structural feature in fats, the lipids, the fats and oil, in oils and other lipids. Very common feature we see every day. They are found in fruits and in flowers. They're commonly also found in fruits and in flowers. I want to use yellow. In fruit and in flower. Most importantly, look at what they do. Now, they have very good fragrances. So their fragrance, they have very good fragrances and represent some of the nature's most pleasant smells or odors. Those very good smells or odors usually come from ester products. Now they are partly responsible for the fragrance of bananas, pineapples, oranges, strawberries, and so many other fruits. So that is the reason why they are commonly used as flavoring agent in foods and in scents in personal products. A very common example is ethyl butanoate is the strawberry flavor. Ethyl butanoate is the strawberry flavor. Then what is this ester functional group? Now the ester functional group is the carbonate carbon single bonded to oxygen. Of course, this is the carbonate carbon. Of course, you know that. And this looks like an ester. So when you put them together, this becomes so this is the carbonate carbon with this oxygen. You know, from here now is the carbon connected to oxygen. So when this oxygen is connected to the carbonate carbon, we have the ester functional group. So the ester functional group, okay, let me use a different color. This is the ester functional group. Like I said again, a carbonate carbon connected to an oxygen is the ester functional group. And of course, we call it carboxylic esters because they are usually made from carboxylic acid. Remember in the last module, we said with one of the reactions of carboxylic acid is that they react with alcohols to form carboxylic esters. So now this bond between this single bond between the carbonate carbon and oxygen is what we call the ester linkage. Now let us now go to the IUPAC nomenclature because that is the crux of the matter in this class. Now the nomenclature is very simple, and in fact they can even be more complex, but at the level of this class we're going to be putting it very simplistic. Now the first word of the name of the ester, remember technically esters are made from, I'm going to change that color, an acid. The carboxylic acid is made from acid plus an alcohol to form carboxylic acid ester. So to name them, we go back and name them from these two parts. This is how we name them again. Now see what happens. The first word of the ester is the name of the alkyl or the aromatic group that is contributed by the alcohol. So what it means is that we take the name of the alcohol, and the second part we also take the name of the carboxylic acid. So the combination of the name of the alcohol and the carboxylic acid and a little change is what gives us the IUPAC name for esters. Now, the second word, on the other hand, is the second word is the carboxylic acid name. Now, what changes here? Just like we talked about when we did the nomenclature of carboxylic acid salt, is that we're going to be dropping the IC in the acid and now be replacing it with what? With ATE, as if we're naming the salt. That's exactly what is going to happen. So if you have ethanoic acid here, if you have ethanoic, you're going to be dropping this, and then it's going to be no, you're not going to put ATE. You're going to put ATE. And then if you made it from an alcohol, you're not going to put first the name of the alcohol immediately. So looking at this, what I have here, looking at this structure, now I found out that this is the ester functional group. Of course, we know this is the ester functional group. Now, this side, this is the part that is contributed by the carboxylic acid. Let me just say carboxylic acid. This part is the part contributed by the carboxylic acid, and this part comes last in the nomenclature. This is the last part you say in the nomenclature. And remember, it's gonna end with ATE. Whereas this part is the part that is contributed by the alcohol. This is the part that you name first. So we're gonna see how these play out. Okay. I just looked at what I did here. I think I made a mistake here. This is supposed to be ethanoate. I didn't put the O here. So okay, let me not forget that should be OATE there. Ethanoate. That's what. So I didn't put the O there. So it's supposed the O is going to be the what you're changing is not the IC, replacing it with these ones. Just very important for me to make that correction. Now let's take some reflection questions as examples to make sure we drive home this nomenclature we're talking about. It says name the following esters. Remember what we said? It said the first part is the part. So you have to know the part that is contributed by the alcohol, and you have to know the part that is contributed by the acid. And it is very much easy to do that. It is very, very easy to catch that. How do we catch that? It's very easy. Okay, look at what we do. Now, to catch that, we're going to look at this structure. So look at this structure now. Remember, this carbon is the carbonyl carbon, usually carbon number 1 here, right? Is the carbon number 1. This carbon number 1 has the carbonyl carbon. That means that anytime you see that carbonyl carbon, this part is the part that is contributed by the acid. So this part is what is contributed by the acid. What it then means is that this part is contributed by the alcohol. So now, this part contributed by alcohol, what is this? If you look at this now, if you look at this, what does this look like? This looks differently. This is isopropyl. 1, 2, 3. So this is isopropyl. So this is isopropyl is the part that is contributed by alcohol. Then this side that is contributed by the acid, I'm going to change my color. Let's count it. The number of carbon. Because remember, the carbonyl carbon is carbon number 1. So this is going to be 2, 3, and 4. So it has 4 carbons. If it does have 4 carbon, what are we going to say? We're going to say this is what? A but. Since we're going to be changing, the acid is butanoic acid. So what it means, remember, this is the acid part. So if the acid here is not going to be butanoic acid. So what it means is that I'm going to be changing this. So this is going to give me butanoate. And then I'll put this. So the name is going to be isopropyl butanoate. Now to name it, I'm going to remove all this stuff so that I can now name it properly. Those were illustrations. So the name of this side is the what comes first. So the name of this one will be the name of the alcohol part is isopropyl. And the name of the acid part, we said, is the butanoic acid. But if you remove the IC and put ATE, it becomes butanoate. So this is isopropyl butanoate. That is how we name this. So this is called isopropyl butanoate. We now go to the next one. Let's look at this one next. In naming this one, okay, let's say this one. Okay, let me say this is A. This is going to be my B. This will be my C. This is going to be my D. So in naming the B part, let's go and name the B part. In naming the B part, again, whenever you have the carbonic carbon, know that that place is the side that is contributed by the what? Acid. So this side now is contributed by acid. And what is the longest chain? Here is 1 and 2. So it is ethanoic acid. So we're going to call it ethanoate. Now what it means is that this the other part is contributed by the alcohol. And let's count. Here is going to be 1, 2, 3, 4. 4. Remember, it's going to be named as an alkyl group. So it's going to be a butyl group. So this is going to be butyl. And this is ethanoic acid. If you remove the IC and put ATE, it becomes ethanoic acid. So what are we going to call this? We're going to call this butyl ethanoic acid. But we're going to remove the IC and say ethanoate. So this is butyl ethanoate. Remember, this part was contributed by the alcohol and this part was contributed by the acid. Now we go to the C part. In the C part again, this is the side that is contributed by the acid. We know that. This is the part contributed by alcohol. So we know how long is this? This is 1, 2, 3, 4. So this is going to be butanoate just like this one. 4. What about this side? Let's count this side. 1, 2, 3, 4. This is going to be butyl. So to name this now, this is going to be what? Remember, this is butyl here. 4 is butyl. This is butyl. So we're going to say this is what? Butyl 1, 2, 3, 4. Butanoate. Butyl butanoate. That is how we name this compound. Now, the last one in this page again, to name it. Okay, let's see. Now, this is the part contributed by the acid because there has a carbonic carbon here and this oxygen. So we know this is from the acid. Therefore, this is from the alcohol. This is the part from the alcohol. And what do we call this? This is 1, 2, 3, 4. So this is tet butyl. It's going to come first. So we're going to say tet. Remember, tet butyl has a hyphen. Tet butyl. Now let's count the chain here. This is 1, 2, 3. This is propanoic acid. So we're going to remove the IC and put ATE. This is going to be tet butyl propanoate. Tet butyl propanoate. That is how we name esters. I told you the nomenclature of esters is not that difficult and it's very, very easy. So for the next reflection question, you can easily pause this video, try out these things yourself, and come back to check for comprehension. All right. So this one says, name or draw the following esters: propyl benzoate, cyclopropyl ethanoate, then these two. So I'm going to say this is A. I'm going to use my blue again. So I'm going to say this is A, this is B, this is C, and then this is D. Now, this one says withdraw. So let's try to draw. Now remember, this side is the side contributed by the alcohol. Usually comes first. This is from the alcohol. This side is from the acid. Don't forget that. So you can start drawing it from anywhere. It doesn't really matter where you want to draw from. It doesn't really matter that much. So now benzoate means it's from benzoic acid. So I can decide to draw that one first. Let me put the side from the acid. Let me use my normal red. So the side from the acid, I can put it first. So this is benzoic. Now benzoic acid means it's going to have C, this double bond, and OH. Now, but remember, we're not drawing the acid. What it means is that the propyl group is going to come from here. So this is, if you put this now, this is the benzoic acid, but that is not what we want. I'm going to take this away again. If you take this away, so what I want to do is to connect the propyl group from here to form the ester. So connecting it is going to be, propyl means 3 carbon. So it's going to be 1, 2, 3. Let me just label, see what I got. 1, 2, 3. Yeah, so this is the structure of propyl benzoate. This is how you draw this structure. Then we go to the next one. Let's draw this one again. This one says cyclopropyl ethanoate. Ethanoate is the side from the acid. This one is from the acid. The acid gave me this. And then this is what? The alcohol. alcohol gave me this. So what it means is that cyclopropyl means this is a propyl group, but a cyclic one. So it comes from cyclopropane. Then, but let me first of all do the acid. If I put the acid, the ethanoic acid first, which is 2 carbon. So what am I going to have? I'm going to have, okay, let me draw it with the carbons. This is ethanoic acid, 1, 2. But that is not what I want. So what that means is that I'm going to take away this. This is not what I want. So what do I do next? I need to now put the cyclopropyl. Cyclopropyl is just 3 carbons this way. The triangle, that's cyclopropyl. So what I'm going to do, I'm going to connect this to the triangle. So this is you name it, cyclopropyl ethanoate. That is how you draw the structure. Now the last two says, name the following. We're going to name it because the structures are already there. Again, we count. Now, usually I don't test you with these ones that has an attachment. But to name it is very easily. It's very easy. Do you know what you do first? In every case, you have to name the part that is contributed by the what first? By the alcohol. So the part that is contributed by the alcohol, of course, if you see this is from the acid. What it means is this is from the alcohol. So I'm going to name this. What is this? This is, no, that's a mistake. So this is 1, 2. So 1, 2 means ethyl. So I'm going to say ethyl. That is ethyl. Ethyl. And then this part, I'm going to count it. The part that is contributed by acid, of course, the carbonate carbon is carbon number 1. This is 2. This is 3. This is 4. So if it is 4, assuming you want to name the acid that has 4 carbon, it's going to be butanoic acid. So that's exactly what they're doing, butanoic acid. And if it has an attachment in carbon number 3, this is methyl group, remember. So you're just going to say 3-methyl butanoic acid. But this is not an acid. You have to remove that IC and put ATE. So we're going to say this attachment is carbon number 3. So what do? Don't put dash. In this case, leave a space and say 3-methyl 3-methyl, and then you now say the name. The name of the acid is butanoic acid. You remove the IC and put ATE and throw away the acid yourself. So it's going to be 3-methyl butanoate. Ethyl 3-methyl butanoate. That is how we name these ones with attachment. The same thing we go for this one again. Again, you look at this. The part contributed by alcohol is this. What it means is that this side is contributed by the acid. So this is from alcohol. Of course, this side, let me just do that. That helps. This is from the acid. So this part again is isopropyl. This is isopropyl. So I'm going to write it first. Isopropyl. Remember, this side from the alcohol is isopropyl. Don't just misunderstand it as if I'm naming it. This is isopropyl. It came from alcohol. This came from the acid. So isopropyl. Now, let's count the chain of the acid, of course, starting from the carbonate carbon again. This is 1. This is 2. This is 3. This is 4. Oh, still 4. So what it means is that it's going to be butanoate again. But look at this. There's an attachment in carbon number 2. So what are you going to say? You're going to say 2-bromo butanoate. That is how you name it. So this is isopropyl 2-bromo butanoate. That is how you name that particular molecule. And having said that, we've come to the end of this lecture today. I told you it was going to be a short lecture. Thank you once again for listening. Bye.